Welcome back to Billy and Joy's classroom. But before we proceed, please do not forget to click the subscribe button and notification bell so that you always be updated for our latest video. Then do not forget to follow our Facebook page, Billy and Joy's classroom. For today's lesson, we are going to talk about geometric sequence. Basically, we define geometric sequence as a sequence of numbers in which we can get the succeeding term by multiplying the previous term to the fixed number called the common ratio. Okay? But before that, at the end of this discussion, you should be able to illustrate a geometric sequence, differentiate a geometric sequence from an arithmetic sequence, and determine the nth term of a given geometric sequence. Okay, for example, we have here a given geometric sequence which is 2, 4, 8, 16, and 32. So, based on our definition, we get the succeeding term by multiplying the previous term by a fixed number called common ratio. So, what do you think is the number that is being multiplied to the preceding term to get the succeeding term? So, to get 4, we're going to multiply 2 multiplied by 2, so we get 4. Then 4 multiplied by 2, we got 8. Then 8 times 2, we have 16. Then 16 times 2, we have 32, and so on. So the fixed number 2 is called the common ratio. So the common ratio for example number 1 is 2. How about for the next example? So we have 32, 16, 8, 4, 2, and so on. So to get the next term, we are going to multiply 32 by 1 half. So we have 16. 16 multiplied by 1 half. So we have 8. 8 times 1 half. We have 4. Then 4 times 1 half, we have 2, and so on. So the fixed number that is being multiplied is 1 half. So therefore, the common ratio is 1 half. Okay. Now, how do we able to get the common ratio or the R? Okay, so to get the common ratio R, divide the second term by the first term, or simply a sub 2 divided by a sub 1, a sub 3 divided by a sub 2, a sub 4 divided by a sub 3, and so on. So for example, determine the common ratio of the given geometric sequence. 1, 3, 9, 27, and 81. So to get the common ratio, divide the second term by the first term. So we have 3 divided by 1, we have 3. Then 9 divided by 3, we have 3. Then 27 divided by 9, we have also 3. So therefore, the common ratio for our first example is 3. Let's have another one. We have 48, 24, 12, 6, 3. So what do you think is the common ratio? So we have 24 divided by 48. So if you notice, our fraction is already in proper fraction. So we're just going to simplify it by dividing number, both numerator and denominator, to reduce the given fraction to its lowest term. So what do you think is the number that can be divided in both numerator and denominator? So we have 24. So 24 divided by 4 is 24 divided by 24, that is 1. Then 48 divided by 24, that is 2. So therefore, we have 1 half. Okay, let's check another one. We have 12 divided by 24. So divide both numerator and denominator by 12. So we have 12 divided by 12, that is 1. Then 24 divided by 12 is 2. So we have 1 half. And let's try another one. We have 6 divided by 12. So simply divide both numerator and denominator by 6. So we have 6 divided by 6 is 1. Then 12 divided by 6 is also, that is 2. So therefore, we have 1 half. So our common ratio for example number 2 is 1 half. Now, will you please try to find the common ratio or R in the following problem? You can pause the video to try to find the common ratio. Okay? So if your answer for number 1 is 3, you're correct. How about for number 2? What do you think is the common ratio for the given example for number 2? So we have 1 half. Okay? And for number 3, we have 2. Now for this time, we are going to solve for the nth term of the geometric sequence. So in geometric sequence, we have the formula that is a sub n is equal to a sub 1 multiplied by r raised to n minus 1. Okay? So that is the formula. Okay. So a sub n is our nth term. Then a sub 1 is our first term. And we have r is our common ratio. Then n is the number of terms. Okay, let's try. Okay, so this time let's try to solve for the nth term by this given problem. Okay, so we have here a problem. What is the 9th term of the sequence 2, 6, 18, 54, 162, and so on? Okay, so we have the formula that is a sub n is equal to a sub 1 multiplied by r raised to n minus 1. So let us substitute the value. We have a sub n is equal to a sub 9. Then we are given a sub 1, which is 2. Then we have the common ratio that is 3 taken from dividing the a sub 2 divided by a sub 1, or 6 divided by 2. And then 18 divided by 6. So we have the common ratio that is 3. Then we have the number of terms, or n, that is 9. So by substituting the value, we have a sub n is equal to 2 multiplied by 3 raised to 9 minus 1. So let us first subtract the exponent. So we have a sub 9 is equal to 2 multiplied by 3 raised to 8. So remember, 3 to the 8th power is not 3 times 2, or 3 times 8, I mean. So the exponent tells us how many times the base to be multiplied. So we have 3 raised to 8 is look like this. Like that. Okay? So we have 3 raised to 8 is equal to 3 times 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 3, or simply multiplying 3 8 times. Okay? Repeatedly. So we have 3 raised to 8 is equivalent to 6,561. So we have a sub 9 is equal to 2 multiplied by 6,561. So 2 times 6,561. So the value of our a sub 9 is equal to 13,122. Okay? So let's try another one. What is the 8th term of the sequence 5, 10, 20, and so on? So the formula is a sub n is equal to a sub 1 multiplied by r raised to n minus 1. So we have a sub n is equal to a sub 8, and then a sub 1 is equal to 5. Then our common ratio, that is 2 by dividing 10 divided by 2, then 20 divided by 10. So we have 2, and then we have n, that is 8. So let us now substitute the value. We have a sub 8 is equal to 5 multiplied by 2 raised to 8 minus 1. Again, let us first subtract the exponent. So we have a sub 8 is equal to 5 multiplied by 2 raised to 7. So 2 raised to 7 is not 2 times 7. So it is 2 raised to 7 is equal to 2 times 2 times 2 times 2 times 2 times 2 times 2. Or we're going to multiply 2 7 times by itself. So 2 raised to 7 is equal to 128. So we have a sub 8 is equal to 5 multiplied by 128. So 5 times 128, so that is a sub 8 is equal to 640. Okay? Let's have another one. Find the seventh term of a geometric sequence that is 2, 6, 18, 54, and so on. So again, we have here our formula. A sub n is equal to a sub 1 multiplied by r raised to n minus 1. So we are looking for a sub 7. Given our a sub 1 that is 2, then our common ratio is 3 taken from 6 divided by 2 and 18 divided by 6, 54 divided by 18, so that is 3. And then we have n, which is our number of terms, that is 7. So let us substitute the value. We have a sub 7 is equal to 2 multiplied by 3 raised to 7 minus 1. So we subtract first the exponent. So we have a sub 7 is equal to 2 multiplied by 3 raised to 6. So 3 raised to 6 is equivalent to 729. Okay? So we have a sub 7 is equal to 2 times 729. So 2 times 729, so that is 1,458. Okay. Let's have another one. Given the geometric sequence 150, 25, and so on, find the sixth term. Okay? So we have again the formula, that is a sub n is equal to a sub 1 multiplied by r raised to n minus 1. So we are looking for the sixth term. So we have a sub 6. Then given our a sub 1 is 100. Then we have our common ratio, that is 1/2. So we have 50 over 100. Then 25 over 50. So that is a proper fraction. So we're just going to simplify by dividing both numerator and denominator with the same number. So we have the common ratio, that is 1/2. Then the number of terms is 6. So let us now substitute the value. We have a sub 6 is equal to 100 multiplied by 1/2 raised to 6 minus 1. So let us subtract 6 minus 1. So we have a sub 6 is equal to 100 multiplied by 1/2 raised to 5. So we're going to distribute 5 to both numerator and denominator. So we have 1/2 raised to 5 is equal to 1 raised to 5. Then we have 2 raised to 5. So 1 raised to 5 is equal to 1. Then 2 raised to 5 is equal to 32. So therefore, 1/2 raised to 5 is equivalent to a sub 6 is equal to 100 multiplied by 1 over 32. Okay? So let us simplify now. 100 times 1 over 32, that is 100 over 32. And simplifying the answer, so dividing both numerator and denominator by 4, so we have a sub 6 is equal to 25 over 8. Okay? So do you have any question? I hope you have learned today. Thank you.